Hello friends, welcome back. Hearty welcome to you. Let's look at this interesting example as part of coordinate geometry. Straight lines. Line ax plus by plus p equal to 0 makes an angle of pi by 4 with line x cos alpha plus y sin alpha equal to p. If these two lines are concurrent with x sin alpha minus y cos alpha equal to 0, find the relation between A and B. So we have been given three lines here. These two lines have an angle of pi by 4. So we can use angle between the lines and we can get the relation here. And we have these three concurrent. So we can take a point x1 comma y1 and try to get a relation between them, so that we can start from here, try to convert this x alpha sin alpha cos alpha in terms of x1 y1, then go and convert that again back into alphas sin alpha cos alpha x1 y1. So we should be able to get a relation between A and B. So let's go ahead and try to solve this. Okay, fine, good. So we know the first thing is the angle between them is pi by 4. So let me go ahead and write down that angle part. So we'll write down tan alpha. Angle between two lines is given by tan alpha equal to m1 minus m2 by 1 plus m1 m2. We have an absolute value there. So we'll consider one scenario. You can take the second scenario. I'm sure you will get the same answer. Okay. So the slope of the ax plus by plus p equal to 0 is minus a by b. And slope of x cos alpha plus y sin alpha equal to p is minus cos alpha by sin alpha. How we got that? Convert that into y equal to mx plus c, or for ax plus by plus c equal to 0, slope is minus of a by b. Now let's go ahead and substitute these values. We will have tan alpha, that's nothing but tan pi by 4, is equal to minus of a by b minus m2, that is plus cos alpha by sin alpha, divided by 1 plus m1 m2, that is 1 plus a cos alpha by b sin alpha. Let's go to the next step. We know that tan pi by 4 equal to 1. So can I go ahead and write down 1 equal to, I will have b cos alpha minus a sin alpha after simplification. And that b sin alpha in the denominator will cancel, so I am not writing that. I will have a cos alpha plus b sin alpha in the denominator. So this part will cancel out. So next we will have b cos alpha minus a sin alpha is equal to a cos alpha plus b sin alpha. Now if you get b's to one side, I will have b cos alpha minus b sin alpha. We'll try to get b's. We'll get cos alphas to one side. I will have b minus a into cos alpha is equal to a plus b into sin alpha. Or can I write down our important observation that sin alpha by cos alpha, sin alpha by cos alpha is equal to b minus a divided by b plus a. This is our observation. So that's the first relationship we got between the angles and a and b. Okay. So what we did is we just applied the formula tan alpha equal to m1 minus m2 by 1 plus m1 m2. We have taken one consideration where it is plus 1. The other value will be minus. You can do that. You will get you will get sin alpha by cos alpha is actually a plus b divided by a minus b in that scenario. But at the end, final end, both the scenarios will satisfy the particular condition what we are trying to deal with. Now we have been told that all these three lines are coincident. So let us say that x1 comma y1 is a point which satisfies all these three lines. Let's go ahead with that. Now let's take second and third lines. Our lines are x cos alpha plus y sin alpha equal to p, x cos alpha plus y sin alpha equal to p, and x sin alpha minus y cos alpha equal to 0. Now if you are able to substitute x sin alpha equal to y cos alpha, you will immediately, let's try to solve this. Okay, what we will do is, we'll try to put y value. Okay, I'll write down here. From this I know x sin alpha is equal to y cos alpha. So I'll go back here and I'll write down x cos alpha plus y is nothing but x sin alpha by cos alpha, and multiply that with sin alpha, which is equal to p. If you simplify, you get x cos square alpha plus x sin square alpha is equal to p into cos alpha, or can I say x equal to p cos alpha. If x equal to p cos alpha, easily we can see that y equal to p sin alpha. That is one more observation we got. This is our condition number 1, this is our condition number 1, and this is our condition number 2. So with this we should be able to go to our first line, that is ax plus by plus p equal to 0. Or these are actually, all of them are x1 y1, because x1 comma y1 is a point, so it should be x1 equal to p cos alpha, y1 equal to p sin alpha, where x1 y1 is a point which satisfies all the three lines because they are concurrent with each other. Now we are ready for the final step. Let's go to the final step and close this. Now we know ax1 plus by1 plus p equal to 0. ax1 plus by1 plus p is equal to 0. But what is x1? x1 is p cos alpha from 2. So can I write down ap cos alpha plus bp sin alpha plus p equal to 0? Can I take p common throughout? Can I say a cos alpha plus b sin alpha is equal to minus 1, if you are okay with me? Then can I go back and write down now cos alpha sin alpha values? For that, what we do? We know that sin alpha by cos alpha is b minus a. So you take that alpha, sin alpha is b minus a, cos alpha is b plus a by something. By Pythagoras theorem, you can check that a minus b whole square plus a plus b whole square is 2 into a square plus b square. So this guy, hypotenuse will be square root of 2 into a square plus b square. Now we can leverage that values and we can substitute them here. We will do a into cos alpha. Cos alpha is a plus b divided by square root of 2 into a square plus b square plus b sin alpha, b into b minus a divided by square root of 2 into a square plus b square. This is equal to minus 1. We are just 2 steps away from our final answer. Now we simplify that. We get a into a square plus ab. We get a square plus ab plus b square minus ab. Can I write down that in numerator? A square plus ab plus b square minus ab divided by square root of 2 into a square plus b square, and that is equal to minus 1. Can I simplify anything here? ab cancels, a square plus b square by, that is nothing but a square plus b square divided by square root of 2 into a square plus b square is equal to minus 1. We simplify this. Root of a square plus b square will go one time. I will get root of a square plus b square is equal to minus of root 2. You square it on both sides, you get a square plus b square is equal to 2. So the relation between a and b in this particular scenario is a square plus b square equal to 2. m2. So before winding up, let's see what's the approach we have followed to solve this problem. We have been given that two lines make an angle of pi by 4. That means I can use the formula tan alpha equal to m1 minus m2 by 1 plus m1 m2. The second thing, all these three lines are coincident with each other. So second and third will give me one relation between x and alpha. The angle will give me relation between sine alpha, alphas and a and b's. So that I can leverage and I can go back to the first line. I should be able to get the relation between a and b. That's one interesting example which I thought of sharing with you. So thanks for your time and support. I'll catch you once again with another interesting example. Till then, as usual, keep smiling and sharing. Life is short. Bye for now.